All right. My name's Neal,
My name is Bakhom Aziz.
I'm Nadia.
and our presentation is over optimizing chiller plant efficiencies.
So, for our project, we were optimizing a chiller plant by trying to improve performance and energy efficiency. And the different types of chillers available are water cooled, air cooled, evaporative condensed. And we had several ways of optimizing these chillers, and some of them include variable speed drive and screw type. For the different types of chillers, we had water cooled, which uses water from an external source to cool refrigerant into the condenser where it's turned into a liquid form. And for air cooled, it uses ambient air and additional to reject heat from the refrigerant. And for our baseline model that we used in the simulation, we had a centrifugal water cooled chiller, and this chiller used the compressor to cool water, and it's known to be efficient.
So the first upgrade that we implemented was a variable speed drive using two centrifugal water cooled chillers. And so basically, what the VSD does is that if you have a regular pump, a regular centrifugal pump, it pumps out a constant rate GPM. But with the VSD, it corrects it to like the required amount of GPM rather than having like excess water being used. So that saves with water and money that way. And then the other one, we had a rotary screw chiller. And so basically, what that does, it's generally more cost effective because there's less moving components, less maintenance costs, and they're pretty helpful when you have like fluctuating loads, and they accommodate well to cooling temperatures. Another one that we used was free cooling, aka an economizer. So basically, what it does is that it uses the cold ambient air to cool down the water in order to minimize energy used to refrigerate the water. And then one of the main reasons why people use it is because it reduces the CO2 emissions on overall, and generally it reduces the overall energy consumption by the whole machine. And for this one, we had two centrifugal chillers, one running at 75% capacity and the other one running at 25% capacity. And this one best suits loads that fluctuate a lot. So if you have one chiller running at a higher capacity, this helps with the varying loads.
So the fifth case study that we did was dry cooling. Basically, what dry cooling is, it uses ambient air to reject heat from a fluid process rather than using water for cooling. It's usually hitting a heat exchanger where usually water or glycol flows through the tubes and the air is drawn over these tubes to remove air. Um, the HAP model data that we have collected, if you look on the right with the bar chart, you realize that most of them are about in the same range, within like $15,000 per year. Screw type being the lowest amongst them at $85,340. And then there's two equal centrifugal, with the VDS at 87,600, and then $100 extra is without the VDS, just two equal centrifugal. The most expensive one to have is the free cooling. And if we go to the simple payback period, we use a simple equation. Our baseline was our current power. We subtracted the new power, and then operations, we did it 24/7 for the whole year. And then we multiplied that by the electric rate, which was 0.12 for us. And then we multiplied it again with 12 months. for the data that we have collected, the best one for the best investment would be the screw type. 3 years and the investment will be paid off, and after that is just savings from there. The free cooling is probably the worst one since it was worse than our baseline. You were spending more money to run that one, so that's why it's a negative number. In conclusion, the best performing one was the VDS 2 chillers on split load, 75 and 25, and then a screw chiller for partial load efficiency. The key benefits of this project was to lower power consumption, reduce maintenance costs, and better system flexibility. Free cooling showed poor performance in all metrics, and takeaway is basically smart chiller selections and load management drive sustainability and cost efficiency. And that is it.
And then here's our references.